Hey guys, I wanted to go over my solution for problem 13.4. So we're asked to consider the motion of these three directions of x. And the first thing we're asked to do is find the Lagrangian of velocity and acceleration. So what we can do is use equation 13.6 here in the book. It's essentially your standard finding velocity and acceleration. You just take the derivative with respect to time. So if we do that for x1 here and x2, these are the two equations that we get, and then of course v3 is just 0. All right, for acceleration, it's very similar. You just take the velocities v1 and v2, take the derivative again with respect to time, and then because of the exponential functions there, they're just a flip of what we got for the velocities. Okay, part B, you're asked to determine the Eulerian of velocity. The first thing you want to do here is you want to invert the motion. So the big X's that we're using for Lagrangian, we want to switch those with the small x's that we're using for the Eulerian reference frame. So here's what we start with. And then for x1, here's the algebra to do that full switch. So we're looking at big X1 on the left-hand side, and then only small x's on the right-hand side. And then this is what I got. And then for x2, it's very similar. This is a starting equation, algebra, and then that's my final answer right there. Okay, so we take those inverted motions and we substitute them in to our part A velocities. So I repasted those here. That's there and there. And so pretty simple. I just you could simplify it maybe a little bit, but I just plugged them directly in here and here to get your final answer. You could distribute the exponentials along the numerator there if you wanted to. Okay, so for part C here, we're asked for the Eulerian acceleration in two ways. The easiest way is just to invert the motion again. So as I put here, you're just going to substitute the inverted motion big X1 and big X2 into the acceleration that we found in part A. That's those two equations here. And then we just plug it in, and there we have it. Again, you could simplify it a little bit if you wanted to. So the final way we're asked to get the Eulerian acceleration is through the material derivative. So that's equation 13.12 here at the top. So that's it in general form, and that would be it trying to find the acceleration. So if you plug all those in from our Eulerian velocities, which I did here, that's what you get. And then going through the algebra here, using the product rule, this is where I get it, and I didn't simplify it. I couldn't really figure it out, or I didn't take the time to go through it, but you should get the same answer you got from inverting the motion. So if someone went through that, let me know, commented. Thanks, guys.